Hello friends. So here I am uploading a video on data lake. So if you are working with open table formats when storing your data in a data lake house, so this tutorial will helpful for you. So traditional data warehouse solutions have some problems like they have limited scalability. Okay, though when your data grows, so it is difficult to horizontally scale the entire cluster. And when you work with any data warehouse solutions, they are vendor lock-in. That means you have to keep your data in a proprietary systems. Okay, and there is two structured data. So if you have data on unstructured or semi-structured data, it is difficult to store. So to solve all these problems, the data lakehouse solutions are evolved, right, where you can store all this variety of data. Another thing is what is open table format, right? So if I'll tell you by the definition, open table formats are database like capabilities to object storage. So when we store a data in a database, so the retrieve is very effective or efficient, right? So when you store data in a data lake like in a object storage, so they are all file system data. So when you keep a file system data in, like, just try to imagine if you are trying to keep your data in a CSV format or in a Excel format or in a JSON format, then you are trying to retrieve the data. Okay, so it is difficult. Difficult means they don't give you acid-like properties which the data of this storage systems are, right? So to overcome these challenges, these open table formats are evolved, where you can store data in a tabular format or in a database tabular format in any object storage like your S3, ADLS, or if you are working with any on-prem solutions like on MinIO as well. So when you store data in a open table format, it has two layers basically. So one is data layer where it stores all your data in a multiple parquet files. So parquet is a data columnar data file format. Then it stores all the metadata of your data in a separate JSON files, right? And it maintains the versions. So any write you will do, so it will maintain a version of your data, right? So with this you can get advantage of your data lake house solutions. So you can build ACID capability, or ACID stands for atomicity, consistency, isolation and durability, where these database tables basically support. So this ensure like all your transactions to your data table are never lost. So if there is a failure or there is a partial commit, so always it roll back to your original states. Then you can do time travel. So this is a peculiar problem when you create a data pipeline. So customer always want to roll back or need to see data on a particular time. So with this you can go to that particular time stamps and see your data. Then schema evolutions, with this you can rename your tables or you rename your fields. You can change the data type of your fields. So this will never impact your data pipelines or your data. So when you work with a complex data lakes or data warehouse, so this is a pictures you always need. So as you know, open table formats can bring a database like reliability of data lakes. So you can imagine how helpful they are. So multiple open source tools are there which support open data tables. So one of them is Apache Iceberg. So they created by this particular tool is created by Netflix. Now it is widely adopted by Snowflake or Drumeo. So it is maintained by Apache community right now. Then Apache Hudi, so it is it also a open table format like data lake house. It is created by Uber, and the good thing is it specializes in real-time streaming, ingestion, and incremental processing, right? Then Delta Lake, which is a robust data lakehouse tool. Okay, so this has been created by Databricks, and you can see it's a mature system which support this transactions, time interval, and update and insert in your particular rows of a data, right? So now let us see a demo how you can write your data into a delta lake table. So I have created this video on delta table, and you can see the data in a data lake storage like Minio. So I have used Minio over here. So let us see the demo. So in this tutorial I have used the delta lake library to inserting and reading from a delta lake table. So here is my import statements where I have used multiple libraries starting from delta lake to panda, OS and time, and this is my delta lake table path. So here I am using Minio for the storage. So in this delta lake demo I have created this bucket in my Minio storage, and I am trying to write this particular data set in this path, that farmer DB is the directory, and my open table farmer collection would be farmer registrations. This is the sample code which create a synthetic data which I wanted to write in my delta table called farmer registration. So here I am creating basically a farmer data sets having these columns. So let me execute this. So you can see my data points. So the 6 column data farmer ID, name, age, gender. So these are the columns I have created, and I have created six records. Now I need to write this particular data frame into a delta lake table. So this is my code. Let me execute this. Yes. Now you can see my code is successfully executed. Now this delta table will be created in my Minio. This is my Minio instance. So I am running it in my local. This is the bucket name, delta lake demo. When I refresh this, so you can see there is a directory called farmer DB is created, and inside that a delta lake table which is called farmer registration is successfully created. So if you are trying to see this table, so as we discussed earlier, like there is a file called Python file is created which holds the data basically. This is the Python file, and all the metadata is stored in a folder called _delta log. And inside that there is a JSON file which stores basically the metadata of these tables. So this is how the delta table is created by using delta lake rs library. Now let us do some more operations. So here I wanted to see the version of my data. So I told all the data stored in by maintaining a version like Git on your database, right? So it is showing current delta table version is 0 because I have one write as of now. Now if I want to see the data, the code is dt.to panda. So I converted this data into a pandas data frame. You can see all my 6 records are there in this delta table. Now let us do some let us do another operation by writing 2 more records into this table. So this is my second data frame which contains 2 more records, and I am writing like this 2 records into that delta table. So here I will use the mode of append. Okay. Yes, so now these 2 records are successfully added into my delta table. Let us see. If I refresh this, you can see another Python file is created which contains the contains another 2 records along with the 6 records, and also there is a separate metadata is created. So every insert or update is created another versions of your data, right? This is how a delta lake table basically maintained. Now suppose I wanted to see the data what I have created recently, so I need to read modify the recent delta table. So you can see all these 8 records are available now. If you want to see the version of my recent data, it is showing the version is 1. Now as I told, I can do a time travel of my data of my table. So if you want to see the version 0 of my table, just the code is I need to set the table path along with the storage options I have used, and I only mention the version 0 I want, right? Then I converted the data table into a panda data frame unit to see in this notebook. So here it is. You can see this is my version 0 table. So this is how the delta table basically keeps the data, and you can use a read and write operation by using delta table RS. RS means the ROS package, delta lake ROS package. Thank you. So again I will bring another video on data lake, so stay tuned my channel.